Be telling us about mining controller inputs.
Hi, it's great to be here. So today I'd like to talk about categorizing video games. Think about a video game that you'd recommend to someone. And if you don't play a lot of video games, then a movie will work just as well. Chances are, if you were to describe that game to someone, you'd start by describing some of its more general aspects, such as being a platforming game, or in the case of a movie, a horror movie. Then you'd move on to describing some of the specifics, such as being a platforming game with only one button, or a horror movie that doesn't have jump scares. But if you look at the way that we currently categorize video games on the PlayStation Store, on the App Store, on game review sites, they only talk about the specifics, or the general stuff, like it's a platformer, it's a shooter, but nothing more. So here are two examples of both games that are classified under racing. The first is Forza Motorsport 6 on the Xbox One, and the second is Kirby Air Ride on Nintendo GameCube. While it's true that they're both racing games, they're wildly different from one another. So we wouldn't necessarily recommend Kirby to someone who likes Forza. But that's exactly what our current categorization methods do. What's more, there are games such as Uncharted 4 that offer a variety of gameplay types, or a blend of gameplay types, such as shooting, puzzle solving, exploration, and even domestic life. But these games, too, we only describe usually with just one word. In this case, it's an action game. And so what we'd like to propose is a different way of categorizing video games. Rather than using traditional genre labels, why not categorize them according to their actual gameplay types, how they actually feel to play? So here's where the research lies. In order to build a system that can take a game and categorize it into using a blend of gameplay types, such as Uncharted, we need to figure out a few things. First, we need to find some kind of signal that we can observe within the game to learn about the types of gameplay that it fosters. Second, we need to figure out how to represent the concept of a gameplay type itself, since that's pretty abstract. And third, we need to then actually categorize the game. And since we're considering each game to be a blend of gameplay types, that means A, finding out what those gameplay types are for that particular game, and B, finding out the extent that each part of the game fosters each of those gameplay types. Let's start with the first one. So this is a theoretical problem that requires us to define the term gameplay. And my favorite definition is the one offered by Katie Salen and Eric Zimmerman in their book Rules of Play. I'm going to show you that definition in visual form with a picture of a game as a more finite state machine. So here's the picture. The game is the big box on the bottom. It takes input from the player, and then it outputs graphics and sound, which in turn influences the player's next action, forming an interaction loop between the player and the game. And so that interaction loop is actually the definition of gameplay. And the point at which that loop is most salient is actually right here, the player's controller inputs. And so this is what we're going to observe. This is the signal to learn about gameplay. This is in stark contrast to current game analytics systems, which generally work by logging events that take place in the game, such as items collected, enemies defeated, things like that, and then analyzing those logs later. Those systems could be thought of as observing this edge, the point at which events occur and the game state is about to be updated. So now the second thing we needed to figure out was how to represent the concept of a gameplay type itself, since it was pretty abstract. So to do that, I'm going to show you some footage from Super Mario Bros. 3, which is the focus of our case study, and then I'm going to show you what controller inputs actually look like. So here's Super Mario Bros. 3. We chose this game for three reasons. Firstly, it is one of the highest grossing video games of all time. Second, the player directly manipulates Mario, so what happens in the game is very visible in the controller inputs. And third, the Nintendo Entertainment System controller has just two buttons, so figuring out what's going on is actually a harder problem. Speaking of the controller, here it is. The directional pad on the left moves Mario, the A button makes Mario jump, float, swim, or fly, and the B button makes Mario throw fireballs, grab items, open treasure chests, and more. And this is what controller inputs actually look like. This is a portion of the stream of the gameplay that you just saw. So the trick here, these bars actually indicate when the buttons were pressed, by the way. The trick here is that to find gameplay in this, we need to see the dynamics of the game playing out, which means sampling a sliding window of this stream and then forming what we're going to call input words from that window. So in our case, the window is this size. It's 30 frames, which is half a second worth of inputs. And we'll slide that window along every 10 frames. So for the first few frames, right is the only button that's pressed. And so R is going to be what's called the input state for that period. The input word for the window will simply be the sequence of input states over that window. So semantically, input words represent gameplay primitives, or the building blocks of gameplay. Let me show you what some of those words look like. This word represents making a jump with Mario and then holding left at the end to stop his momentum. It's just half a second. And then this word represents making nimble swimming movements in water. A key property of input words is that semantically similar input words tend to occur together. So this was one swimming-related word, and immediately after it, you're going to see more swimming-related words, such as these. This property leads to a very natural definition of a gameplay type, a set of frequently co-occurring input words, which we'll assume are semantically similar. So here are some sample gameplay types that I'm just throwing out there. So then the next thing that we needed to figure out was how to actually then categorize games by blends of gameplay types, which meant A, figuring out what those gameplay types are for a particular game, and B, figuring out the extent that each part of the game fosters that gameplay type. So to do that, it turns out that if we treat this as a case of probabilistic topic modeling, we can figure both of those things out at the same time. Topic models allow you to take a corpus of documents, such as news articles from the New York Times, and find what the underlying topics in that corpus, such as sports, politics, science, etc., actually are. They also, for each article, return that article's blend of topics. So in this case, this article on climate change, for example, can be thought of as a blend of 30% science and, say, 70% politics. This is latent Dirichlet allocation, which is the simplest topic model. It's a graphical model. The beta nodes here on the right, there are k of them, are topics, which you can think of as sets of words, like these for science and politics. There are D documents with n words apiece, and those words are going to be W. We only see the text of the articles, and so W is the only thing that's shaded. And from that, we can actually infer the values of these other things, such as what the underlying topics are and what the blend of topics is for each of those articles, as well as which topic each word comes from. So applying this to our case of video game categorization is relatively straightforward. The words will become input words. The topics will become gameplay types, and each document will be a recording of a play session of a particular stage. So in this case, in Super Mario Bros. 3, we had 91 stages. We had a player play through the entire game. It was about 8 hours of inputs, and here are the results. So these are the resulting gameplay types that we found in Super Mario Bros. 3 for each stage. Each stage is a row, and each row sums to 100%. There are 12 columns representing the 12 different gameplay types that we discovered in the game. First thing you'll notice here is that there are some clear outliers, and those actually represent water levels, which play very differently from other levels in platforming games. The bigger picture of this chart, though, is that it is a much more natural and more meaningful way of categorizing Super Mario Bros. 3. Instead of merely calling it a platforming game and nothing more, it's now a blend or a mix of 12 different styles of platforming, and moreover, each stage within the game is a different mix of those styles. So, for example, World 3-2 can be thought of as a blend of 35% jumping around flying enemies and projectiles, and 23% making precise running jumps onto moving platforms. If you played this stage and you liked it, we can actually recommend other levels to you that have similar blends of gameplay types, even ones that don't look so similar at first glance. So I mentioned jumping around, flying enemies, and projectiles. Well, here are flying Cheep Cheeps, Fire Chomps and their fireballs, Podoboos, and Hammer Brothers and their hammers. Moreover, we can also sometimes figure out or infer specific choices that players made within the game. For example, if they were playing a water level, if they played it straight, which is hard, or if they used the frog suit, which is much easier. And that's because those choices manifest themselves in the controller inputs that we observe. This isn't always a good thing, however, if we want a straight ground truth categorization of the game, because we don't necessarily want players' choices and players' playing styles to affect that. And so this is the next problem, is how do we categorize the game independently of playing styles? So to answer that, suppose that we have a stage that's a mix of sneaking and fighting, and our player likes to fight. So you might observe this distribution of input words, and there's a lot of fighting here. So if we use LDA to categorize this, we would assume that the level is just about fighting, because that's what we saw. But what we actually want to do is categorize this level as an equal blend of sneaking and fighting. And so what we did is we created the player gameplay action model, or the PGA model for short, which is an extension of LDA, latent Dirichlet allocation, that adds a third variable into the mix, which is the player's playing style. For our player, that might be this. She almost always fights when given the choice. The trick here to model this is that if we observe the inputs on the right, the distribution, and we know this is our player's playing style, then we want to categorize that stage like so, is to assume that the rightmost distribution is a product of the other two distributions, namely that the other two distributions act as filters on each other. Let me show you how that manifests itself in the graphical model. So here's LDA again. I'm going to color these labels blue so that you can see what's new. And as we morph this to the PGA model, you'll see that we added these variables up here, pi, which are the player's playing styles. Those are going to multiply with the betas, the gameplay types, to form the final words. The other change that we made is that each document, instead of representing a stage, is going to, a playthrough of a stage is now going to represent a particular player, row's playthrough of stage sigma. In our case, we got 8 players to play different portions of Super Mario Bros. 3, a total of about 15 hours of inputs, and these are the results that we got for the PGA model. So this is, again, categorizing the game according on a stage-by-stage basis. And as with LDA, we actually find some strong outliers in the middle there, this middle column. And those outliers, again, indicate water levels. We also discover some of the same topics that we did before, such as there's a topic representing jumping around, flying enemies, and projectiles. That, in this case, that's topic 5. Let me show you, and we also discovered some new topics. So let me show you a few of the new topics or gameplay types. I kind of use those interchangeably that we found with the PGA model. So type 8, gameplay type 8, represents trying to jump on enemies that are moving around sporadically. And gameplay type 3 represents backtracking in maze-like levels. So the PGA model, in addition to providing a categorization of the game, also provides the pi variables, which are the profiles of players' playing styles. So let's look at some of those. So here are 3 of them. The input words here in each player's profile characterizes that player. And so 2 observations here. One is that we can sort of eyeball a player's relative skill level just by looking at the complexity of the input words in their profile. So player 6, for example, has no experience with platforming games, almost no experience, I should say, while players 1 and 2 have a lot of experience. The second thing is that we can find particular habits that each player has when playing through these input words. So player 1 likes to float a lot in the air. Player 2 likes to crouch up and down as Raccoon Mario, or while waiting for platforms. So to see how well that these playing styles actually characterize each player, we built a player recognition system based on its output by modifying the PGA model. Basically, what we did is simply shaded everything except the player indicator on the bottom. And that's because now we have all of the inferences from before. We just don't know who's playing. That recognition system can recognize a player with 90% accuracy in about 20 seconds of playtime, even for stages that the player never played before. Moreover, we can actually recognize a sequence of players as they take turns passing the controller amongst themselves. So to simulate turn taking, we fed the system 45 seconds of input apiece from 5 different players, and we were able to recognize each player within 10 to 20 seconds of them taking the controls. One thing we found is that it's easier to recognize experienced players than it is for novice players, such as Dave and Eve, because there's more variety in how experienced players play. So what did we do? This talk was about categorizing video games into using gameplay types and how games actually feel to play. So the first thing we did was we used some theory about games to identify some kind of signal, in this case controller inputs, that we could observe in the game to learn about its gameplay. Then we figured out how to represent the concept of a gameplay type itself. Turns out we could do one, we could make it analogous to a topic in a topic model, but using input words instead of words. Third, we treated the problem of categorizing the game as a case of probabilistic topic modeling and created the player gameplay action model to both categorize the game, independently of players' playing styles. And lastly, we figured out who's playing by building a player recognition system based on the player gameplay action model, and that also validated the assumptions at multiplication in the model. So a quick word on the future. So these techniques can help power a search engine for games and experiences. So you can imagine that if you just had an experience with a game, or even with like a virtual reality experience that you liked, you could maybe bookmark it and then go back later and try to search for experiences that have similar substance. So we believe that this is the path towards making that happen, mining controller inputs to understand gameplay. Thank you for listening. Did anyone have any questions? All right. Oh.
We'll go you second.
Hey, Nicky Couture, Carnegie Mellon. This is really, really cool stuff. I love the...
Where are you?
I love...
Where's
hello.
Nicky? Oh, okay.
Over here.
Thank you.
Hi. So I'm wondering how well this translates, or what do you have to do to translate across different types of games that, you know, maybe I use B for jump here and A, and then it's switched in the other case, and do you have to do anything to learn the vocabulary mappings for different types of games?
Yes. So to do that, we would want to, instead of mapping raw button presses to input words, we would want to map basic actions, jump, run, things like that. That would be the first step. I tried this on racing games, and we got some interesting results, so I could talk to you about that. And one of the areas for future work is to try this on fighting games as well, to figure out who's playing, what character they're playing as, how good they are at playing the game, and to maybe help coach the player. So.
Other questions? Back on the left there.
Hi, Andrew Webb, Texas A&M University. I was wondering if you had thought any about how game designers might actually be able to use this information. I was thinking about looking for areas of like repetition where the gameplay might be getting boring. I was wondering if you could speak onto that.
Yeah. So I believe that game designers can use this type of system to, as you mentioned, make sure that there's enough variety in the game, and also to kind of use this as a sanity check to make sure that a level that they designed actually plays the way that they thought. So one of the big problems in game design is what's called emergent complexity, where a level is designed, let's say, for the player to sneak, but then maybe fighting is a lot more rewarding, and the player might just want to play the game as they want to play it. And so a whole bunch of things could happen that the designer didn't originally intend, but those things would nonetheless manifest themselves in the controller inputs. And so you could see, well, hey, you designed the level to be about sneaking, but it's actually about fighting. and then you could make changes without having to hard code event logs, such as, oh, he actually killed a lot of enemies to sneak or something like that.
Yeah, one more question. You had your hand up first, so we'll go with you. Thanks.
How do you think this applies to more open-ended games like simulators or strategy games?
So this works best in games where players directly manipulate the main character, so that what the player's doing in the game is manifested in the controller inputs. For a point-and-click game or things like that, like you could imagine a StarCraft type game, this sort of system wouldn't work as well. But in the general case of simulators, like think avionics or flight simulators or such, this method should work just as well. And it should also be able to profile the pilot in the case of a flight simulator and figure out how adept that person is.
Okay, great. Thank you. Let's thank our speaker.